Welcome to class number 83. See, earlier classes, same questions solved. Left side UDL, right side UVL. Same way. One question this way, one question this way. For both those questions, maximum BM was somewhere here and here. That is in the UDL part. Or shear force diagram, see, it will cross the baseline between these 2 points. So, why two question means once UVL is going this way, once UVL is going this way, just to understand. One of them was main question, one was practice question. But today, I am making more main questions because now in today's class, this question, the maximum BM will come somewhere in the UVL part. That is somewhere here. Therefore, see, when it comes somewhere here, to locate that point, for this question, you take x from here. For this question, you take x from here. So, both I will solve. But one thing remember, all these are thoroughly over earlier. Therefore, I will write the steps and calculation, then explain thoroughly. That is better. If I write everything in front of you, it will take some time, and in between, time is wasted. And if any mistake is there, I have to correct that one. That is calculation mistake. So, I will start the questions now. Question number 1. I wrote here. Solution for question 1. VA, VB reactions. See. Minus VB into 7 plus 30 into 3 into 3 by 2 plus half into 4 into 60 is the total load. It will pass somewhere here. From here 2/3. So, 3 plus 2/3 of 4 equal to 0. You get the value of VB, sigma V0, VA plus VB minus 30 into 3 minus half into 4 into 60 equal to 0. You get the value of VA. We are ready for SFD BMD. I will start now. SFD BMD. We will continue. I have drawn the beam here with the reactions. Draw shearing force diagram. Okay, I will do one thing. Now, first I will tell how to draw shear force diagram without showing calculation. Take your calculator. See, start from here. Go up by 93.571. From A to C, come down linearly or gradually this way by 30 into 3 is 90 kN. From 93.571, come down by 90, still you are above the baseline by 3.571. Then from C to B, again come down by half into 4 into 60, that is 120 kN. But remember UVL, therefore parabolic variation. So parabolically come. Okay, you reach here and then lastly go up by 116.429. Or shear force calculation. Shear force at A, slightly you have to come inside, plus 93.571. Shear force at C, plus 93.571 minus 30 into 3, total load, over. Shear force at B, whatever you got here, minus half into 4 into 60. You get the shear force calculation, right? SF variation is linear for AC and parabolic second degree for CB. Now, important, see. A to C linear. This slope is already fixed here. Now, C to B is parabola. At C, to the left side, intensity is 30. So, this inclined line will have slope of 30. But for the right side, intensity is 0 there. So, here, parabola with 0 slope. See, therefore, not this way. Not this way. It is this way parabola. So that if you draw a tangent here, it should have 0 slope. Here, maximum slope. This all told for you many times earlier. Now, some statement, dash, dash, dash means in my class, I am dictating something. Those who are serious should note down. Go back and draw shear force diagram with all the principles I told just now. Observe the shear force diagram and check or observe there. Is there any point where SFD crosses baseline and decide known point, unknown point? See, SFD will cross the baseline here. It is an unknown point. So that point you have to locate. Why means I cannot answer now. Or last time I will tell, next time I will not tell this one. This point permanently now. Unless you locate that point, SFD is incomplete. Second one, that is the point later where bending moment is going to be either maximum or minimum. These, for all these cases, maximum, minimum will come later. So actually either maximum or minimum. That all you write there. Now onwards, this I will not tell. Okay, start. Location of the point between C and B where shear force is 0. Let shear force be 0 at a point X, at X from C. Very important. Write a note. If you take X from here, when you look this side, you are going to get trapezium. Better avoid trapezium and go for triangle. So take X from here. See, next question, it will come here. Then you should take X from right hand. That I will tell you at that time. Okay. Now, after I complete, I will briefly explain, or for those who are serious, what you will get if you take X from here. What you will get means, it will come same answer, no change can come. Okay, start. Shear force at X. Actually, you can enter all that one here only, but no, it will spoil the diagram, so that's why I am entering here. After you get good grip, you can do and make all these entries here itself. So till you get control, separate sketch. See, somewhere here X. It is 60 here, 0 here, intensity is W suffix X. Get it? 60 by 4 is here, into X will give 15X Kn per meter is the intensity. Now, at present 15X, enter there. Now, shear force is 0 here. Remember, this I told in mathematical class number, I don't know the number now, go through all those 3 classes. Shear force here, look this side, plus 93.571 minus 30 into 3 minus half into X into 15X. Equate to 0, you get the value of X. Then substitute X equal to 0.69, your 15X intensity will become 10.35 Kn per meter. Enter everything. Or if you know the concept, if I am solving, what I will do is, I will write shear force. First of all, I won't write anything. I directly get my calculator. That is separate, leave it now. So shear force at X equal to, at the point C, you know shear force. How much? 3.571. So instead of writing these two, you can just write 3.571 minus half into X into 15X you can write. Answer will come same. Okay, now substitute everything, ready for BM calculation. Start. BM at A, 0, look this side. BM at C, look this side. Plus 93.571 into 3 minus 30 into 3 into 3 by 2. You will get the answer. Or if you want, make a note. If you look this side, no problem. Plus 116.429 into 4 minus half into 4 into 60 into resultant will, the total load will pass here, 2/3 of 4. You will surely get same answer. There will be some people now who will comment themselves. He looked this side, he took clockwise positive. He looked this side, he took anti-clockwise positive. If they tell in front of me, I will ask them, what is clockwise, anti-clockwise for bending moment? How many times I have to tell? No, I came first time today. If you came first time, go to first class. From there start studying. Not suddenly in between. Suddenly you start from here if you are already knowing everything. If you are knowing everything, then you won't ask such questions. Okay, sorry, just for fun I told. I always in the class also talk that way. But my students know that I show little angriness or not somewhat little rough. They know it. It is for fun only. Then I laugh and tell. I will ask them, any hard feeling? They will tell, no sir, no hard feeling. Because we know your purpose is to improve our knowledge, not to scold, get happiness by scolding. I am not such person. Okay, start now. What happened now? All over now. Now lastly, BM at X. Look this side. Don't look that side. If you look this side, plus 93.571 into 0.69 plus 3. I wrote 3.69 minus 30 into 3 is the total load moment about this point into 0.69 plus half of 3. Lastly minus half into 0.69 into 10.35 is the total load. It will pass here into 1/3 of 0.69. You get the BM 147.356. See, slightly more. Okay, now, lastly, BM variation is parabolic second degree for A to C, parabolic third degree for C to B, and be careful, at this point, shear force is 3.571. Both sides slope should be same. A common tangent will be there. There will not be change of slope here. See this point. Same slope will continue. But it will go a little higher. And at this point, where shear force 0, if you draw a tangent here, slope should be 0. These all told endless number of times. Make a note, write everything, and complete the bending moment diagram. Study thoroughly. The purpose of this class, some will tell, he is solving same question. No, not same question. See, last time, your SFD cost baseline here, now it is here. There will be reason if I solve the same type of question second time, third time, fourth time, or 100th time also. Some reason will be there. Just for time pass or extending the class, I will never do it. So, already reached class number 83. So, I should think of closing the course. No, I will close the course when everything is over. Okay, start. Now, I will just explain to you now. Suppose you take X from here, what will happen? Remember, only for those who are serious and dedicated. I'll just check the camera from that side once. Okay, no problem. Because I had a doubt. The wire pulled the tripod slightly, so I had a doubt. Any shifting means I have to re-record it now. See, now, all this over, just to understand, do one thing. Just you take X from here. Actually, never take. This is called unnecessary asking for trouble. Okay, X here. Then this ordinate Wx will become, see, Wx will become 60 by 4 into 60 by 4 into how much? Into 4 minus X. I write here now, directly, the intensity will become 60 by 4 into 4 minus X. X should be black, red color. Or it will become 15 times 4 minus X. 4 minus X. Okay. This is the intensity. Now, remaining all, I will just explain I will talk and explain. You make a note if you are serious. See. Now, shear force 0 here. Look that side. Right side you are seeing, right up is negative, minus 116.429 plus total load here, 15 into 4 minus X plus 60 divided by 2 into X will give the total load equate to 0. 100% your X will come. See, this is called confidence. I am not calculating. I got already 0.69 from here. 0.69 minus 4. 3.31 meter. Guaranteed will come. Okay, X came. Now, BM, substitute 3.31 here, you get the intensity. 4 minus 3.31 into 15, it will come 10.35 kN per meter. It has to come because whether you take X from here or X from here, it is the same point, intensity has to come same. In my class, it will come. Okay, now, look that side. Start. Bending moment calculation. BM here equal to plus 116.429 into 3.31, that is positive bending moment sagging, minus moment of this load, 10.35 plus 60 divided by 2 into 3.31 is the total load. It will pass somewhere here into this distance is 10.35 plus twice of 60 divided by 10.35 plus 60 into 3.31 by 3. I will not calculate. It will come 147.356 kilonewton meter. Yes, that's how Those who are serious, make this note. Others, I think others will not be listening to this one. Why? They will have stopped earlier and started studying something else. So that way, solve this one now. Now, I will go to second question. Problem is, even second question, it will take little time. And since I explained little more than required here, it consumed already little more time. So I will do one thing now. I will do second question in next class. As usual, people want class of smaller duration so that they can study. Now present age, if I put class for 45 minutes, people will see such a lengthy class. No, cut questions or short classes, but coverage is complete. Okay, I will solve in class number 84. There I will tell solution for second question given in previous class and solve. And I will maintain, I will write this question here. That's all. So these both will not be visible then. Or if it is visible also, I will tell class this question I am starting. I will rub everything now and solve everything at that time and solve second question. Okay. See you in class number 84. Thank you.